Welcome again to the STEM series. This time we are doing Tier 3, which is about embedding STEM or STEAM in your schools from an interdisciplinary approach as usual. And we are going to show a sample project just like we did in the past two presentations. And just a quick reminder, previously in the STEM or STEAM playlist, we had setting foundations presentations, one concerning the 6 criteria and the 3 tiers as an introduction, and then part 2, how you identify which level your school is in on this kind of scale. And we did also a presentation about Tier 1 and Tier 2, and now today we are going to do Tier 3. So just a quick reminder of what we discussed last time. We need first to present a pathway for the most effective STEM or STEAM systems in our schools. So obviously we need engagement, and that's the key in any kind of system. So we have to do essential engagement planning. Obviously here we have 5 elements: professional development, curricular activities, extracurricular activities, challenges, and partnerships. And here we work on 2 levels. We work on leading and teaching, which means leaders and teachers. These are the adults in our schools, and learners, of course. And in the two group of stakeholders, we are definitely emphasizing the role of females in STEM learning, because we really need to involve more of the females in the STEM learning. And we also work in parallel with the essential engagement planning on the SMART framework. And as we know, here we are emphasizing on goals that are specific, that are measurable, that are attainable, that are relevant, and that are time-based or timely. We have to emphasize that STEM is not a curriculum. It's much more than just having a STEM lab in our schools. It is more than just having robotics classes. You can have a STEM lab, of course, we need to have that, a STEM space or STEM hub, whatever you want to call it. You want to have those groups engaging with each other and interacting with each other. But when we talk about STEM system in the schools, we are talking about something that is complex. These are disciplines that are interconnected. They are project-based, they are problem-based, and so on and so forth. Because here the goal is to solve real-world problems, to learn how to solve real-world problems in effective or using effective methodologies. And as we do that, we are building career pipelines, because we all know, and we have been discussing that in all conferences, summits, forums. We are emphasizing the need to have new understanding, impart a new type of knowledge that involves careers as we build for the present and the future. So how to identify or enhance your school level. This is a chart that you have been familiar with. If you haven't watched the previous presentations, I encourage you to do so, because it explains that in detail. Also Tier 1 and Tier 2. Today we are doing Tier 3. So now we have a well above average STEM system in our schools. It's an advanced stage. So definitely here, the 5 elements that we have mentioned before: professional development, curricular activities, extracurricular activities, challenges, and partnerships, they are done at a more advanced level. And this is what we will be dealing with in this presentation. So before we move into anything else, we have to mention monitoring progress and impact, because as we all know, our work has to be systematic, has to be coherent, has to be built on evidence and on data. So that's why we have to monitor progress and impact. And I always like to incorporate here the instructional model, or the rainbow of 21st century skills. It's been used until this very day. That was initiated in 2015. You already have it. We talked about it last time, but it is comprehensive. It brings all the disciplines together. It brings all the skills and requirements together. And I find it one of the most powerful models. Now, talking about the Tier 1, Tier 2, and Tier 3, we have to be working on the what we know as 4 C's, but now we are taking them to another level. In Tier 2, we added character. In Tier 3, we are working on 7 C's. Now, in some schools, it may be 5+ or 6+. We keep it open, because it's all, like we always say, based on your school capacity. But I always encourage to have the 7 C's in tier 3, because here we are adding the climate and culture. We are focusing on the climate, which is the perceived social and psychological environment in our classroom, and here in direct relation to STEM or STEAM implementation. So whereas the school culture, it's this set of values and beliefs of the school, it mainly relates to how people act within the environment. So now while we are doing tier 3, we are working on more than just the 4 C's that we all know. We are working more than on just adding character. Like in tier 2, we are adding climate and culture as well, because this is how you can achieve direct and effective engagement, full engagement, and embedment. So again, just to sum up how we talk about the interdisciplinary. So usually we know that STEM or STEAM, as disciplinary, we mean science, technology, engineering, arts, and mathematics. It's all in one. But now when we're working on setting a system in our school, we have to think about domains that are beyond science, technology, engineering, arts, and mathematics. We are thinking about other disciplines, which we call them non-STEAM, and the other disciplines that will be supporting STEAM. So we are talking here about SNS, or STEAM, non-STEAM, supporting STEAM. Now, when they are separate, just like the 3 circles on the left, this means that they are disciplinary. Well, if we just bring them together, they are multidisciplinary. Today, here and in these presentations, we talk about interdisciplinary. They are coming together, interrelated, and this is very important. We also have transdisciplinary, but that is a bit complex. We will not talk about it, at least for now. So when you initiate your STEM or STEAM committees, you are thinking to have this interdisciplinary approach while working on all your STEM projects. So here, definitely you're bringing the 3 committees, you're bringing the STEAM, non-STEAM, supporting STEAM together. You are allocating those tasks. You are thinking of the members. So you will have the leaders of the head science teachers, whatever, what relates to science, what relates to computer or technology, what relates to engineering, what relates to mathematics, what relates to art. And you're also bringing, like I said, if we're talking about the non-STEAM, language arts, social sciences, sports. Again, they are the leaders, the head teachers, the teachers, and the learners. And the supporting STEAM, these are the non-academic staff. They are also parents. There are the community, companies, organizations around you within your community. So they are all coming together to work on this, because like I said, STEM is it's not about subjects. It's about disciplines that are brought together to help the community reach certain solutions. And we mean here innovative solutions. So starting together with the professional development, and here we mean rigorous PD, but this is at level 3. So rigorous PD 3, we're talking about also 7 C's, 21st century skills throughout our professional development that's being conducted. And here we are obviously implementing the computational thinking, but now we are adding a percentage to our school. So now we can handle at this level in our school 40 or 50% of our team having those, at least the basic computational thinking skills. So bringing it all together, I think this is a very easy and simple layout, which we can put all our points together. So like I said, if we're talking about PD, we are asking ourselves, what are we training? What are we mentoring, coaching? And who are we mentoring and coaching? Academics, non-academics, alignment of standards, and this is very important. And here we must generate a foundational scientific capability of our community. And this is not very easy because, like I said before, in many presentations, there's always a level of resistance in a way or another, especially, for example, from the non-STEAM group. And here, if we're saying, well, what is rigorous PD 3 or level 3 or the advanced or the well above average, here we are not only talking about teachers or the people involved learning reacting to whatever concepts they are being given. Here we are studying their behavior, and the behavior that will lead to a higher impact, to a deeper impact as well. So now the level of the professional development is higher. It's taken to a new baseline. So again, with the rigorous PD3, we are talking, like I said, about the standards, different standards. And when we mention the STEAM and non-STEAM, the supporting STEAM, we mean these whatever organizations, companies, parents who are involved in certain disciplines who can come and help. But again, this is at a higher level. We are involving deeper type of knowledge and implementation. So with the 7 C's, we're adding climate and culture, like mentioned, and this is still part of the PD. This is what all the groups will be learning, and we're adding here climate and culture, and I explained what climate and culture is. So the climate is how people feel about certain incidents that happen, whereas the climate is, or the culture is how people act. And culture in particular serves long-term. So it is very important that you understand first your culture and you work within this positive, healthy culture, because with culture, it's different to change, whereas with climate, you can still make some changes, but culture is already embedded in the system. So when you're creating this scientific capability in your school, you want to make sure that it's long-term, and whatever residues from the past are handled, whatever introduction you are, introducing a material, introducing practices are being accepted in a very effective way. And the computational thinking skills here, like I said, we are adding an average. Here, it's not 10 to 20, not 30 to 40, it's 40 plus. Of course, it depends on the capability of the school. For example, in the American system, they have their computer science framework, the K-12 computer science, or CS framework. It has 5 core concepts and it has 7 practices. For example, according to European standards, they have the computing and informatics. So it differs from a school system or education system to another, but whatever that is, we have to work on certain standards. And here, when we're talking about computer science, we have to understand the relation between algorithms and programming. And algorithms is the formulation and the design of the problem, or sorry, of the solution, whereas the programming, it's the implementation problem. So you're designing the solution, but at a different level, you are putting this into implementation. And again, we're like mentioned, we are always keeping an eye on our 7 C's, because this is a core part. So thinking of the sample project or the prompt, I thought this is a very good example here, because it's a bit complicated, which is food industry. And the prompt can be, for example, that food industry has been having serious complications and challenges. Try to solve some food industry problems, find a methodology to put all that into action based on design thinking and computational thinking skills. So here at this stage, it's still the PD. We are still in the first element, professional development. So obviously the group involved are the adults, so not the learners. They will have first to understand the prompt, to understand what they can present to the learners before they just get immersed in the process with the learners. So the main objective here is to train those adult stakeholders how to assist the learners and how to take this topic into the most comprehensive and effective way possible, handled in the classroom. So how do we take this into action? And here we think of 6 sessions during our PD. There are the session 1, session 2, session 3, etc. We will discuss the first 2 because these are the most complicated ones, because these are the 2 sessions that will involve all the adult stakeholders during the PD. So here we're bringing we are bringing the science department and teachers, science technology, engineering, art, and mathematics. We're bringing them all together along with the non-STEAM. So here we mean the language teachers, sports, and all the other disciplines in the school. We're bringing a parent or parents or guardians involved in the food industry. We're bringing some, again, those who will be our partners under the term partnerships supporting STEAM. So they all come together in the first session, sit together, discuss the prompt, and see how they can build knowledge and the consensus on what they want to do. And the second session, again, the stakeholders now, after discussing that separately, they come together and they share whatever they have found. They want to show what they agreed on, what topics they will be working on, etc. So this is a very simple way of starting it. Now, I thought to share a little bit of the discussion topics. These are obviously samples, because once you start working in your schools, you will feel and you will witness an influx of information, ideas, innovative plans. So, and I always encourage that. I always leave it open, because we don't know how brilliant ideas we can come up with. So with the discussion topics and the samples, for example, obviously we're starting with the STEAM, committee, this biology teachers, chemistry, environmental, physics, whatever. So here we're still focusing on the system of education involved, British system, American system, how they handle their standards, alignment with the standards. We're considering the level as well, the age level. We're considering the stages, whether it's primary, secondary. Here we are focusing on food industry, and we mean here material and human resources, manufacturing as well, delivery. Now, when it comes to life science, obviously it's about plants and animals, and definitely humans, because these are humans are the one who will consider the nutrition and the nutritional value. Physics, for example, the food physics. So here we're talking about thermodynamics, food polymers. We will probably discuss the structural design principles, manufacturing and delivery technologies. With chemistry, for example, we will obviously think about food processing, because this is one of the major issues in our food industry in the past 3 decades or even more. We can consider also mycotoxins, for example. This is the toxic substance that is caused by this mold growth on animals, on plants, and then will be eaten by animals and then transferred to humans. So this is very serious. And chromatography, for example. Chromatography is this process of separating components of a mixture. Environmental science, obviously, we are thinking about reducing waste, for example, waste management, waste streams. Earth science, again, we're talking about soil structure, we're talking about the minerals, we're talking about water, we're talking about climate, atmosphere, etc. So with the technology, or the technology group can talk about the factory automation and how it facilitates processing and manufacturing. We can talk about optical and acoustic inspection techniques. We can talk about chemometrics, and this is how AI and machine learning help in and physical and chemical nature as well help in studying the entire process of food. And we can also talk about 3D food printing, although personally, I have some concerns about this, but this is something that can be discussed, because at the end, we want to bring all those discussions to the table, from the adults, then to the learners, so that we can have a comprehensive view of the entire topic. And engineering, for example, machinery involved, the operations involved, food safety, management system as well. In art, we're doing posters. Obviously, that's posters, paintings, food art crafts, food art exhibitions, carving fruits and vegetables. They are very, very nice, especially if we do that for the little ones, kindergarten, primary classes. Mathematics, we are studying ratios, quantities, data, statistics. For the non-STEAM, those are the journalists, whatever coverage in our paper, school newsletter, our cookbooks. We can think of cookbooks, ebooks, conducting researches, case studies, and supporting STEAM. Obviously here, the parents or guardians who are involved in the food industry, they come and share also their experiences, food companies, organizations, farms, factories. It becomes quite interesting. And one thing that I would like to include in this presentation is the terminology. I could have, or I should have included it in the previous presentation with tier 2, because terminology is so important. But here I want to stress that terminology varies by level, and terminology is a core aspect of all this learning, of all this project-based learning, because the more terms they learn, the more ready they are for later stages in their lives. So for example, food science, foodomics, conventional foods, modified foods, functional foods, what else? Consumer behavior, palatability, biosensors, pesticide standards, food contamination. The list is endless. And again, we say it's per the capacity of the school and what you can bring into the discussion. We can share also some STEM coding material or STEM tech tools, because now we are incorporating more of the tech aspects, especially in tier 3. So I'm sharing here just a list of, definitely you have some more to share also. But while we are doing all this, we are doing it as experiential learning. We are collecting data, we are collecting evidence so that we can base our evaluation and data management later. We are working on engineering and technology alignment. So we are not only doing science and math or art, we are focusing also on the standards of engineering and technology. So again, back to the prompt now. Once we have done the first 2 sessions, now we have enough information. So we move on to the 3rd session. They are bringing their plans and designs to finalize them. In stage 4, they are putting that design as a prototype. And then in session 5, they're doing the first evaluation or the testing. And the 6th session, we are presenting this interdisciplinary solution. Conducted in this systematic way, it becomes very easy for the adult stakeholders to take it to the learners now with a very deep understanding of the topics that they want to discuss. So that's when we move to the curricular activities. Cognitive rigor, this is level 3. This is at a higher level, again, as we say. So here, we are thinking about the learning outcomes, not just the goals that we've just stated. We want to have learning outcomes. So all the PD learned in that under that first element is being brought to the learners. And again, with the 3 committees, STEAM, non-STEAM, supporting STEAM. And it's important here to mention, because this involves cognition and cognitive rigor, that computer science concepts, we need to first develop them related to one discipline or in the context of one discipline, of one subject, because you want them to fully understand before they move to the other steps. So for example, if we are doing math, we can focus on the abstraction. If we're doing robotics or technology, we can first focus on the physical computing and so on. So that's important to understand, because this is not easy for the learners to start with. And again, here I want to emphasize the 7 C's, the computational thinking skills, as the mainstreams through which all those discussions are taking place. Now, again, here we have now the same prompt, but now it's the learners. Now it's the learners and the teachers and the adult groups. They're all together working on the projects. And of course, the ideas are endless. And needless to say, we will be fascinated by what children, what adolescents can bring to the table. That's very important. So sometimes you might discover that the learners will discuss certain points that you haven't even thought about during the PD sessions. And this is what makes it very exciting and fascinating to see what learners can think about. So again, here, we're doing the same cycle. We're doing the same path with the first session, second, third, but with the learners involved. And here, the adult stakeholders, they are only serving as facilitators. And just imagine the environment when all these are brought together and they're working on a certain topic. I personally find it amazing. So moving to extracurricular activities, because here we want to focus on another aspect, which is the social emotional learning, social emotional rigor as well. So again, we're putting all this together. It is level 3 now, social emotional rigor added to the cognitive rigor as a tier 3. So here the learners are thinking critically at a much deeper level. They are interacting with each other, they're communicating, they're collaborating, they are working with each other as experiential learning form, and they are creating some models. And this is what makes it very enthusiastically productive in the school. There is a point here to mention that we might think that extracurricular activities are not STEM related, but that's not at all correct, because STEM or STEAM is mainly project-based. And when you are working on the projects, you want to be highly communicative. You want to be collaborating with other people, and this is where it falls into place. And when we say emotional rigor, because you want to have the enthusiasm. Without the enthusiasm, you cannot create new ideas. This is when you are passionate about something, when you are discussing it with your peers, coming out with new ideas, then definitely this is when the level of engagement is much higher and much deeper. So again, the same topic, but in an extracurricular model. So moving to the challenges, this is the fourth element here. Obviously, this is the resistance or the obstacles of setting this into place. So what could those obstacles or resistance be? Now, at this level, tier 3, it's well above average advanced stage. The obstacles here are not much related to resistance, because at this stage, most of the school community is highly engaged, highly enthusiastic, keen at going through the experience. So you will not find much of a resistance, but one obstacle could be the school budget, because you will need here a machinery, you need some robotics, you need material, you need electronics. So this could be a main obstacle for some of the schools. And here that's why I always like to give this as an example. Science Buddies, it's a free website. It started as a public charity, and it involves a plethora of projects that you can check and use in your schools. And for example, in this theme here, when we're talking about food industry, look at how many topics or here projects we can check and see what we can do with our children, so and adolescents. So it's about chemistry, cooking and food science, green chemistry, physics, microbiology, plant biology, genetic engineering, agricultural technology, biotechnology, sociology, human behavior, environmental sciences, geology, weather and atmosphere, computer science, big data. This is endless when it comes to food industry. So these can be some nice ideas to check. And the last one is the partnerships, or the local and the global partnerships. This is the fifth element. And here we're taking it at another level. So we are checking those big companies, big factories, organizations who can partner and help, and in probably sometimes providing resources like material resources. So here, this is open to you, to your school community capability. Again, here we are when we are doing partnerships with other companies, factories, organizations, we are bringing real world information, and this can be a source for learning. So the learners will know more about what is going on in the present in the industry. But what I find it also more engaging is, and more innovative, is to try to think, if we want to progress, if we want to create more innovative solutions, if we want to improve a certain type of tool that you have seen in these factories, so what would you do? And definitely here we can expect exciting ideas. And that's how it is with the 5 elements and 3 tiers. We did tier 1, tier 2, and 3 across the 5 elements. Now at this level, we have already trained our teams. We know that the teams are ready as per their capabilities. So this is okay if we're still in tier 1. What is important is the outcome that we are targeting and the outcome that we can reach. And we can consider it as a challenge for ourselves, for our school community. We can challenge the engagement of the parents. We can challenge the engagement of our community organizations. It becomes very exciting when we are taking this to a higher level. So if we start with tier 1, we can do it thoroughly. We find ourselves equipped with all the skills. We move to tier 2 and then to tier 3. So I wish you a very successful journey in your STEM implementation. And thank you so much for being here, for your time, for your enthusiasm, for your passion to create a new landmark in your schools. And we will definitely in the next presentations talk in details about computational thinking, about the various aspects that we discussed in here after we know where our school stands, whether it's tier 1, tier 2, or tier 3. Thank you again.